How's that? So what I'm looking at here is a 4-variable KMAP. And what we'll do is number the KMAP. And then I'm going to try and come up with a scheme that kind of looks like the presentation on the paper. I think the ones are red. So ones are here, and here, and here, and here. It looks like the X's are black. So let's do that. We'll make the X's black. It looks like that would be right about here. I think I got that right. And the zeros are green, so we'll switch to green and we'll put in the zeros so that it looks kind of like, I don't know, sort of like what it does in the homework. And I think I got that right. Does that look all right to you guys? It looks all right to me. What it says is, given the following KMAP, find the minimum sum of products. Minimum sum of products says we got to make our loops as big as we can, but keep them legit. So my first loop, and I'm going to do this. I'm going to change colors. I'm going to go to blue. I'm going to make a loop that looks like this. What do you think of that? That's a pretty cool looking loop, right? And what would we call this loop? Anybody?
D prime.
That is D prime. That is exactly right. But I'm missing element number 11. How shall I loop element number 11?
Can you loop the entire column?
I surely can. So let's do something in a different color now. I'm going to loop it in yellow because I don't know why. And I'm going to call it AB prime. So now I got two candidate answers. One is AB prime or D prime, and the other is D prime or AB prime. I would say both are correct. And because this is a multiple answer question, you must check both because they're the same forward and backward. So that's how I do that one. Now you tell me, is there an error in the answer key?
I think there is, because I put in AB prime or D prime and I was marked wrong.
You have to have both. You can't just do one or the other. It's a multiple answer question. They're both correct. So
Professor, I think that what I didn't realize was that it was a multiple select answer because it didn't actually say that like in the question.
Really?
Like I didn't realize that it was multiple. I mean, looking at it now, I see that they're check boxes and not like the bullet.
Yeah, the first thing it says to me when I look at it is it says 27 period, multiple answer, colon. It doesn't say that for you?
No.
Wait a minute. Let me get into preview mode and see if I can understand why. I didn't know that. It says edit mode cannot currently be changed. Why is that? Enter student preview mode. Entering student preview. Student preview is on. Course content. I'm going to try and pretend I'm a student going in and looking at homework 4. And now I'm going to hit begin. And let's look at question 27. Question 27. It's a checkbox instead of a radio button. And yes, you're correct. It doesn't say multiple answer, but it does give you check boxes instead of radio buttons. I guess a radio button means you can only select one thing. And then if you select the other thing, it gets unselected. But with check boxes, you got to select all questions that make the answer seem correct. And that is the difference between multiple choice and multiple answer. And in fact, if we look at question 26, it is also a multiple answer question. So this is not unusual. Blackboard allows it. What to do? It's one question. How much is it worth? 2.7 points? Question 27. How many people messed this up because they didn't know it was multiple answer instead of multiple choice? It's got 2 people. Third
I mean,
person.
I still have another attempt, so like
Yeah, if you
could still,
if you have
redo it
enough
as well.
attempts, that'd be good. But here's what I can do. Here's what we'll do. That's a very fine point. Let's exit preview. I'll hit delete the preview user and all data recommended. Continue. Sorry, I'm having a little bit of a Blackboard struggle here. Leave page, save data, stay on page, leave page. Okay, leave page. Okay, I'm going to come back now. Edit mode is on, course content. And here's the way I'm going to fix this. We're going to edit test options, and we are going to increase the total number of attempts. So what we'll do is we'll make the number of attempts go from 2 to 3. How's that? Then you get the highest grade of all your attempts, and that way you can just try again. How's that? Is that all right?
That's great. Thank you, Professor.
Oh, no worries. Now, before you try it again, let's fix some of the other problems. What other questions do you have?
So we went over questions 7, 8, and 9 in class, but I think that like questions 7 and 8 say what is the minimum number of loops we can make, and I don't think we were doing it that way. I don't know. I would
Well,
want
let me try and address that because I did review that before class began. Thank you for your question. I'm going to try and just do that here for the class right now. So this is a 3-variable KMAP, number 7, and it's multiple choice. So you got to choose only one answer, and I'm still in yellow. Let's get out of yellow. And I believe it's A, B, C. Yes, A, B, C. And then we can number the KMAPs. And let's see. It says here, you know what I'll do is I'll change color. 1, 1, and 1. And all the rest are 0. Okay. Now, you tell me, what should I be looping?
Professor, what number is this?
This is, sorry, this is number 7. Homework 4.
Can you loop 0 and 4 and then loop 3?
You bet. That is exactly right. So you loop like this, and then you loop like that. Oops. And now this guy becomes A, B, C with A prime. And this one becomes A, no, it doesn't. It becomes B prime, C prime. B prime, C prime. I should probably be asking you instead of doing it for you. So but the minimum number of loops is 2. And that is what I'm showing in the answer key. Did somebody get a different answer that was marked as correct?
No, but in class we went over this, and I don't think we read minimum, and we said that the number of loops was 3. I don't know.
Well, you can certainly do 3 loops, but you won't get a minimum sum of products. Well, I guess that there must have been an error during the presentation that nobody caught, including me, and that's possible. But now you've got a second attempt, and you know the correct answer, so that will make things right, I hope. Let's try, I mean, the answer key is correct. I may have been screwed up in my presentation, but Nobody's perfect. I think the important thing is you do the work and you get the benefit from it, and that's it. So we just keep trying. I'm not perfect. I probably made a mistake. Let's look at question 8, because that was another one called, what are the minimum number of loops that we can make following the KMAP? So let's have a look. What we'll do is switch colors and make a 3-variable KMAP. 0, 0, 0, 1, 1, 1, 1, 0. Enter. 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. A, B, and C. Looks to me like 6 and 1 have zeros in them. So this has zeros and everybody else has ones. Did I do that right? Yeah. So what do we loop?
0 and 2.
Sure. And what's the name of that loop?
A prime, C prime.
So that's good. What else can I loop?
3 and 7.
Sure. And what's that called?
B, C.
Yep, that is correct. What else can I loop?
4 and 5.
Yep. And what's that one?
A, B prime.
Exactly right. So I got 3 loops. Are they the only loops I could have made? Well, I guess I could probably do something like this. Suppose I did this, that, and this. That would have been legit. That's 3 loops. So that's an alternative looping. In other words, a minimal form is not necessarily unique. Only a canonical form is a unique form. So the green loops give you a legitimate answer. The red loops give you a legitimate answer. Both do. And so as a result, there are 2 ways to loop, but both give you a minimal form with a minimum number of loops, which is equal to 3. What do you think of that? It's good, right? Anybody got confused by that? Who's confused? Be honest. Nobody? How about other questions about homework 4? Or did I answer all the questions that you had about this problem? Does it look
Yeah.
okay? Good, good. All right. And are there any other homework 4 questions? Because that's due tonight. And now you've got a 3rd attempt. So that should be able to fix any problems or blemishes you might have had in the answer, in your approach to the answer. As I recall,
10 and 19.
you want to do 19? Yeah.
10 and 19.
10.
And 19.
10 and 19. Okay, let's do 10. 10 is also a multiple answer question. So this seems to be messing people up somewhat. Maybe that's the reason. Let's have a look. So you gotta kind of, I guess it doesn't alert you. You gotta look to see if you're dealing with check boxes or radio buttons. Believe it or not, it matters. And you'll see that on the test as well. You'll see, check boxes versus radio buttons. It's like a thing. So it says here, I got and then there's this thing they call gray. I'm not sure how to do gray. Maybe what I'll do is I'll make it sort of yellow-y. There, yellow-y. So then it says here, choose all the correct answers for the following KMAP representation. The terms in gray combine to give. The terms in gray, that would be the yellow terms. So if I loop the yellow terms, I get, what's that? Anybody? I don't know if you can see. You know, I'll loop it again in green. There.
A prime B.
Yeah, that's A prime B. And now I'm going to loop something else. Now you tell me, what's my other loop?
1 and 3.
1 and 3, yes. And what's that one called?
A prime C.
A prime C is correct. Thank you. And so now it says here, the terms in gray combine to give A prime C or A prime B. So that's correct. Then it says the term in the lower left corresponds to, now the lower left, I'll put that in blue. Here's the lower left. What does that correspond to?
A prime, B prime, C.
That is looking good to me. So it says here, the term in the lower left of the map corresponds to A prime, B prime, C, which is what we wrote. So I feel that that is correct. Then it says the terms in gray combine to give A prime C or BC or AB. Well, that's not right. So that's not correct. But the first two elements are. All of the above is not correct. And so I have, I don't know, the first two elements being marked as right. What do you think of that? Does that answer your question about question 10? If so, then I shall proceed to question 19. Is that all right? You guys are done with this one? We're done with this. Okay. Okay, we're moving on. So then question 19 says, uh, 0, 0, 0, 1, 1, 1, 1, 0. And then it says 0, 1, A, B, C, 0, 1, 2, 3, 4, 5, 6, and 7. And then, interestingly, everything is a 1. So if everything's a 1, what do I loop?
Everything.
Everything. I loop the whole thing. And what's that equal to?
Isn't it just 1?
Yep. So if f is a function, it's equal to 1. And it's true. 1 is true. Then it says the following KMAP is always false. True or false? The answer is false. It's not always false. It's always true. Always true. So that's question number 19. Always true, right? Because it's not false. It's true. If it was always false, then it would say f equals 0, but we know that's not correct. So it's always true. Is that confusing? Who got confused? It sounds a little confusing. It says the following KMAP is, it might have said the following KMAP is always 0, but it isn't. It's always 1. So false is 0, true is 1. I hold them as equivalent. What about other questions here? Did I answer your question first on question number 19? I said, okay. Are we good with this?
Can you go over 14 and 15, please?
14.
Also, Professor, just to let you know, I think someone in the chat asked if they could go over 12, so just wanted to.
All right, well, let
Let you know
me,
that.
let me do the following here. I'm gonna take a note, unless you guys can keep track. So I got 14, 15, and 12. Anything else? That's it. Okay. I'm just writing it down so I don't forget. Somebody said there's this KMAP. Looks like a 2x2 KMAP. And oh, I used red. I guess I can't use red anymore. So then it says here, this is an exclusive OR. So let's loop it. We're going to loop the KMAP. I'm going to loop that, and we can loop that. What do we call this product term here? Abe, what do you think? What do I call that product term, Abe? Cool. Cool. What do you think?
AB prime.
Yeah, it's AB prime. And what shall we call this product term over here?
A prime B.
A prime B. So now I got F is equal to AB prime or A prime B. And that is the definition of A exclusive OR B. Another way you can do it is you can make a truth table. And write out F. And then you can identify that as A exclusive OR B. What's the difference between exclusive OR and inclusive OR? Where it's A exclusive OR B versus A or, oops, A or B. What's the difference?
1 and 1 is 1.
Yeah, in other words, it's this row right in here. Inclusive OR includes the case where both are 1. Exclusive OR excludes the case when both are 1 and makes it so that the output is equal to 0. So that's why it's called exclusive OR. Right, so you can either show that this is an exclusive OR by virtue of the truth table or by virtue of the Boolean algebraic expression. Either will work. And so the answer is yes. Yes, indeed. This is an exclusive OR. True.
Professor, actually, I got these two right. So if you don't want to go over 15, you don't have to. I'm just realizing that.
Okay. Anyone else want to go over 15? All right then. Well, how about 12? Anybody want 12? Question 12?
Yeah, I want to go over question 12.
Question 12. Okie dokie. Let's do that. Find the minimum sum of products given F equals sigma M of, and I'll just do this in shorthand notation, okay? So this is going to be 7, whoops, comma, yeah, that's right. 0, 1, 1, 0. I'll just write it out. 0, 1, 1, 0, 1, 1, 1, 1, and 1, 1, 1, 0. So this, and this all have radix 10 representations. The first one is 2 plus 4, which is 6. The next one is 15. Oops. And this one here is going to be 14. And so I can probably do it like this. 6, 7, 15, and 14 are this is the canonical sum of products form in shorthand notation, which I list out here for the convenience of being able to fill in my KMAP. Now, did I make any mistakes? 1110. Yeah, that's right. Okay. Does everybody kind of see how I got that? In other words, this part is going to be W, X, Y, Z with Z prime. This is going to be W, X, Y, Z, all non-prime. This is going to be W, X, Y, Z with the first and last ones primed. And if you had 0, 1, 1, 1, that would be corresponding to 7, which corresponds to W, X, Y, Z, with only the first one primed. So that gives you 6, 7, 14, 15, if you want to put it in order. As a matter of fact, it's not even in order, is it? It should be 14, 15, 14, 15, 14, 15. Now it's in order. So I just listed everything in order. So that's a compelling argument that 5, 7, 13, and 15 is wrong, and also not a minimal form. 5, 7, D, and F are wrong, and also not a minimal form. These are canonical shorthand notation forms, and they're not even the correct forms. F equals AB. Well, I don't think it's going to be F equals AB, but I guess we'd have to check to see. So to see what the minimal sum of products is, I can see from the canonical sum of products form, 6, 7, 14, and 15 all get 1s. 6, 7, 14, and 15 all get 1s. Everybody else gets 0s. And then if I go my loopy way, I loop and come up with a number, and it's BC. Think, yeah, BC, which is not AB. Not AB, right, because BC is not the same. It's different. And therefore, none of the above is the way I marked it, which I feel is correct. I feel that is correct. What do you think? Any questions about this one? Or who's confused? Be honest. So none of the above is a legitimate answer, and it's rare. We hardly ever see it in my Blackboard answer keys, but in this particular case, it's correct. And so anyone who thought the answer key was wrong should stop and say, I'm sorry, Professor Lyon, you are correct. It's not much, but it's all I've got. And so there it is. It worked. I mean, I will be wrong from time to time, but not this time. Other questions about homework number 4?
Could you go over question 9, please?
Question 9. Question 9, multiple choice. How many loops can we make in the following KMAP? Let's do that one. Okay, make a nice big KMAP. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0. And let's work this problem. 0, 0, 0, 1, 1, 1, 1, 0. And then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then, did I do that right? Oh, there's another one. And then there's more zeros all over the place. And that looks about right, I think. So how many loops can we make in the following KMAP? Okay. I need help. I need my students to help me. What should I do?
Can we loop 1, 3, 5, 7, 13, and 15?
Um, 1, 3, 0, 1, 2. That's supposed to be a 3, isn't it? Shoot. 1, 3, 5, 7, 13, 15. No, we have to do integral powers of 2. We can do 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So I can do 1, 2, 4, 8, and 16. But what I cannot do is loop 1, 2, 3, 4, 5, 6. I can't loop 6 because 6 is not an integral power of 2. It's a fractional power of 2. So that doesn't work. It violates the rules. It violates KMAP law. And if you can't do the time, don't do the crime. I don't know what the crime would be, violating KMAP law. I guess the KMAP police will get you. What about this one? 10. Can I combine that with anything?
No.
No. So that's all by itself. A, B, C, D. Where do the primes go?
B and D.
There you go. That's exactly right. So we got one loop there. What about the biggest loop I can make here with the element 12?
12, 13.
12 and 13. And what do we call that one?
ABC prime.
You bet. So now I'm left out. What's left out? What's left out? Oh my goodness. It looks to me like maybe you guys should tell me what I can loop next.
You can loop 13 and 15.
Yeah, but you want to try and make the loop as big as possible. How about if we loop 1, 5, 3, and 7? That's a nice big loop. And what will we call that loop?
A prime D.
Yes, yes, indeed. Now, let's get back to our good buddy, element number 15, which we haven't looped. What's the biggest loop we can make for element number 15?
Would that be like 1, 5, 13, 3, 7, and 15?
Well, if you did that, you'd be looping 6 elements. And somebody said you can't loop 6 elements, you got to loop an integral power of elements. You can loop 4 elements. What 4 elements can I loop?
5, 7, 13, 15.
There you go. That's it. And what would that correspond to?
BD.
BD, you got it. So now the question is, how many loops can we make in the following KMAP? And I got to count them. Well, there's 1, 2, 3. Looks like 4 to me. And 4 is the answer. So that's a, one thing I could say about that particular question is it probably should have been reworded just a little bit. And it should have said, how many loops for the MSOP? For the MSOP in the following K-MAP? Question mark. And then it's very clear you're trying to find a minimal form. I guess it was implicit that it was going to be looking for a minimal form, because otherwise I could make a lot more loops. But as a result of finding a minimal sum of products, the number of loops that I make is well known. Other questions about homework 4? Wait, first, did I answer your question about this question?
Yes, thank you.
Okay, good. And then other questions about homework 4 due tonight. No questions?
Can you review the corner rule? I'm not quite sure about that yet. I think that's question 22.
Question 22. Question 22. Yes, indeed, you are correct. Let's do question 22. All right, so you need a 4-variable KMAP. Let's do it in black. Oops. Let's get the eraser out. Then let's go in and it says here, I got 1s in the center. I got 1s in the corners. I got 1s in opposite sides here, and the 0s are all green. And that's what I got, I think. Okay, what do I loop?
So can you loop the 4 corners?
You sure can. You sure can. And if you loop the 4 corners, what do we call that loop? Abe, what do we call that loop? Are you with us, Abe? It's the blue loop. How about Alex? What do we call the blue loop?
The blue loop is B prime, D prime.
There you go. Thank you. And now, what else shall we loop?
The 4 in the center.
Yeah, let's do that. So we'll loop 5, 13, 7, and 15. And what do we call that loop?
BD.
You bet. Oops, 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 oops. And then, well, how am I going to get 14? What should I loop for that? Well, here's a hint. You got your choices.
Yeah, you can either loop it with 14 and 15 or 14 and 10.
That's exactly right. And what do you call the 1410 loop?
AC D prime.
A, no, it's not B prime.
A, C, D prime.
Yes. That's exactly right. Do you see why it's not B prime? Because you see B is changing here. So that gets factored out. In other words, if you had A, B, or A, B prime, you factor out B or B prime, set it equal to 1, and you're left with A. So you don't leave B prime in there. Now, what haven't we looped yet? What about this one here? And loop 4. How do I loop 4? Alexa, would you like to tell us how to loop 4? Anybody?
Can you just do 4 and 5?
4 and 5, you got it. And what's that loop called?
Would it be B, C prime?
Well, I got A is constant.
Would it be A prime, B, C prime?
A prime, B,
C
and
prime.
B prime, C prime. All right, so that's good. And if I was gonna write it out, I would write out everything, right? And so that would be 1, 2, 3, 4, 5 loops. So I would write it, I could write it out, but I don't need to. Are there 5 loops in this KMAP? Wait a minute. 1, just a minute, please. F equals A, C, D prime, or B, D, or B prime, D prime, or A prime, B. 1, 2, 3, 4 loops. There's 4 loops in the KMAP. And what does it say here? There are 5 loops needed in this KMAP. Well, that's false. That's false because we can do it in just 4. Who got confused by this? So I got 4 loops, and that's enough. If I had 5 loops, it would not be a minimal form. And it does use the term needed. So I think that implies the minimal needed. But I suppose I could rewrite it and say needed in, I'll say, the MSOP for the below KMAP. There, makes it very clear. That's pretty good. Other questions about homework 4? And this is good. We're really going through it. I like that. People are really thinking about it. Did I answer your question about this KMAP thing in the corners? Is that all right?
Yes, thanks.
Good, good. I'm not hearing any requests for homework 4. So I'm tempted to move on. Homework 4 going once. Homework 4 going twice. I am declaring homework 4 a done deal, due tonight. Thank you. Let's move on to homework number 5. Homework 5 is due next week, end of day. And let's have a look. How far did we get with homework 5? Do you recall?
Through number 12, I think.
Number 12. Did we finish 12 or did we just get up to it?
We finished it.
Yeah, I think we finished it. It looks pretty familiar to me. All right, let's have a look. This is a basic idea about multiplexers. Let's assume for the moment that I have a 4 to 1 multiplexer. And then I add another 4 to 1 multiplexer. That's 5. Just a minute. 4. So this is a 4 to 1. That's a 4 to 1. And this is a 4 to 1. And this is a 4 to 1. Now I got 4 4 to 1 multiplexers. And what I do is I wire them together and I make a single 4 to 1 multiplexer on the output. And then what do I have here? What's this? Well, on one side, there's 16 inputs, and on the other side, there's 1 output. So this is the equivalent of a 16 to 1 mux. MUX, and then 0, 1, 0 through 15. So we've been able to construct a 16 to 1 multiplexer with 1, 2, 3, 4, 5 4 to 1 multiplexers. First stage required 4 because each one of the 4 multiplexers had 4 inputs. So 16 divided by 4, I said 4, but I wrote 5, but I meant to write 4, is equal to 4. And so I needed to have 4 inputs, had to, in order to make 16 to 1. So then he says, oh no, I need a 128 to 1. 128 to 1. I'll be drawing this until the cows come home. But wait. I don't have to do that, right? Because why? Because the first stage has 128 inputs, and 128 divided by 4 is equal to 32. So if I have 4 to 1 multiplexers and there's 32 of them, (32) is a lot of multiplexers to be wiring up, then I can have 0 through 127 inputs. But then I got an output with 32 wires. So my next stage, divided by 4, is going to need 8 4 to 1 multiplexers. Now, 8 4 to 1 multiplexers will have 8 outputs. But if I have just two 4-to-1 multiplexers, I'll have 8 inputs and only 2 outputs. And then I'll just need one more 4-to-1 multiplexer. So how many do I need? Well, I need 32 in the first stage. I need 8 in the next stage, because 8 times 4 is 32. I need 2 in the next stage, because 2 times 4 is 8. And then I need 1 in the final stage. And by the time I'm done, I'm going to have a number, which is 32 plus 8 plus 2 plus 1. And that is equal to 43, which is what I suspected. And it's fill in the blank. It's not multiple choice. So you have to have an exact match. You've got to type it in. You have to type in the number 43. Blackboard is not forgiving. If you put in a space 43 or 43 in a space afterwards, Blackboard will mark it wrong because, I don't know, because it's a computer. That's what computers do. They don't make mistakes. They just generate error. So there you have it. Question 13. So what do you think of that question? Anybody get confused by that?
Professor, could you just maybe go back to the previous whiteboard page? I just missed one thing.
Back. You want to go back?
Yeah, just to the previous
Just a minute, please.
page, if you don't mind.
I can do that. This one?
Thank you. Yep. Yeah, no, I just missed
Right.
the
So in
last
other words,
thing that you wrote down.
I can make big multiplexers from little multiplexers. That's the message. In fact, suppose these were 2-to-1 multiplexers, and I wanted to build a 128-to-1. Right. So I have 128 divided by 2 inputs means I have to have 64 multiplexers. Then divide by 2 inputs again. I got to have 32 multiplexers. Then I need 2 inputs again. I get 16 multiplexers. I get 2 inputs again. I get 8 multiplexers. I get 2 inputs again. Right? We're doing it out of 2-to-1s. I get 4 multiplexers, and then I need 2, and finally 1. So at the end of the day, I need 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. I'd need 127 multiplexers to make a 128-to-1 using 2-to-1 multiplexers. So I had a big advantage in trying to do this with 4-to-1 multiplexers. Right? It took the number of multiplexers down by a lot. What do you think of that? So 2-to-1 multiplexers. 2-to-1 multiplexers are kind of like this. You got a selector, and then you have an input A and an input B. And it's 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. And this part right in through here, that's when you pick input B. And this part right in through here, that's when you pick input A. And then the output F is going to be B, 0, 1, 0, 1. And here the output F is going to be A, which is going to be 0, 0, 1, 1. And that is how you can come up with a minimal form for your multiplexers. Oops. Number your KMAPs, number your truth tables, 0, 1, 2, 3, 4, 5, 6, and 7. Now it looks like there's going to be ones for row 1, 3, 6, and 7. And now all the rest are 0. And now I can do my looping. And then I got A prime S naught or A B. That all right? I guess it's all right. So presumably I numbered this correctly. I'm just checking. So that's a way to get your something's wrong. Something's not right. 0 0 0 1 1 1 1 0. So 0 1 2 3 is 0. Oh. 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 Shoot. Sorry about this. Ah. So sorry. So sorry. I screwed that one up pretty good, didn't I? Right. So if you do it that way, then you're going to get a different number, a different product term. That is going to be S0 prime B or S0 A. There you go. That looks better. I labeled the KMAP wrong. That would be F. There. So that's a way to derive a 2-to-1 multiplexer using a minimal form with a 3-variable KMAP. So the spec says that when your S0 is 0, your output should be B. And when your S0 is 1, that's your selector, the output should be A. And what you do is you put in S0 as a selector and then A and B. And then here's F. And that's a 2-to-1 mux. There. Now who's confused? Sorry, I screwed up the labeling on the KMAP. This is what
Professor,
happens.
which question is this?
This is just a basic coverage of the content in the book. So this is actually from chapter 4, and it is not one of the questions. It is this is coverage of how you get the 2-to-1 multiplexer in your I think they give you a nice picture of it in your book. Although I don't think they actually give you the same notation that I do. Ah, yeah. So this is a similar to, but not the same as, page 182. How's that? So page 182, what they say is they're using a different notation. They use a 2-to-1 multiplexer with input 0 and input 1, and then selector A. I didn't care for that. And then they use F, and then as an output, or Z, I guess. And then they say Z is equal to A prime I naught or AI 1, which, you know, I guess it all depends on, it's a matter of taste. But then the other thing he does, which I find very obnoxious, is he takes the selector and he pushes it into the least significant bit. Now that doesn't make any sense, because when the selector is 0, you have consistent behavior. It's input 0, which is here. When it's a 1, consistent behavior, it should be input 1. So why would you put the selector in the least significant bit instead of the most significant bit, since it changes the basic mode of the operation of the device. I cannot defend why the book does it this way. It doesn't make any sense to me. And so I redid it so that the selector was in the most significant bit, because otherwise you're changing the behavior of the device every row. And that's just painful and unnecessary. So that's my criticism of this particular way in which the book covers the topic. Nobody's perfect, I guess. But you can kind of see why you'd want the selector in the most significant bit, because it means you can group the behavior of all the rows together. And that basically makes things a lot nicer, in my opinion. Other questions about homework 5? Let's see what we can do. Anybody have a chance to try question 14 maybe? How about you guys? You want to ask me a question about homework 5?
Can we go over number 14, please?
Yeah, sure. I got to clear my drawings because I ran out of space on my whiteboard. How can you run out of space on the whiteboard? I did this nice big iPad, and he wants me to erase. It's silly. Why should I have to erase? So anyway, number 14. Use KMAPs to simplify the function in sum of products form. Okay, so here's this function. And it's giving me canonical sum of products in shorthand notation. And it looks like I need a K-map to get the canonical sum of products. So why don't we do that? Let's do the K-map again. Okay, so it's A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0. And then we do the thingy, 0, 0, 0, 1, 1, 1, 1, 0. And then we number our K-maps, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then it says, let's do this in another color. I like red. 1, 1, 4, 5, 12, 13. And all the others are 0. Did I do that right? I guess that looks all right to me. So then I got a loop. What shall I loop?
Zero, 1, 4, and 5.
Yes, yes, indeed. And what do we call that one?
A prime, C prime.
Sounds good to me. And what else can I loop?
12 and 13.
Well, you could do that, but it would not be a minimal form.
4, 5, 2, 13.
Yes, you want to make your loops as big as legitimately possible. And what do you call that second blue loop?
BC prime.
Looks good to me. BC prime. And it's BC prime or A prime C prime. Yep. That looks correct. Yep. I'm just checking my answer key. Yep, that's correct. So that was number 14. Any questions about number 14? Is it clear why you wouldn't want to just loop these two? Because then you would get something like A, B, C prime. And that would not be minimal. And you can kind of see why it's not minimal, because if you took these two terms, C prime, D prime, and you ORed it with C prime, D, you could factor out C prime and you'd have D prime or D, and that allows you to eliminate D prime or D, and then the answer would be C prime. So you're much better off looping this way because you can eliminate one of the variables in the product term. Variables in the product term. I was searching for the name, but there it is. Any questions about question 14? You guys good with that? Okay, what else can we do? How about doing some don't cares? Shall we try the don't care thing? Question 15's got don't cares in it. That sounds like fun. Let's do don't cares. Created the maximum number of whiteboards. Don't give me this. What is, oh, I see what's going on. Here. Says here, F is equal to sigma M of 0, 1, 4, 10, 11, 14, or sigma D, which is standing for don't cares, 5 and 15. And so then he says, use KMAPs to simplify the following function in sum of product form, taking advantage of the don't cares provided. All right. I think it would be really educational if you guys tried this on your own. So why don't you take a few minutes and give it a try. Anybody come up with an answer?
I got A prime, C prime, or AC.
That sounds correct. And so now, having done that, are there any questions about how we got there?
Yeah, Professor, could you go over that?
I sure can. All right, so let's do that real quick. In fact, we can take our time doing it. So what we'll do, make a little space. let's use red for don't cares, 5 and 15. We'll use green for the ones. We'll use blue for the zeros. That's so very colorful. And then what we'll do is loop. What shall we loop? You tell me.
0, 4, 1, and 5.
Sure. So if we'll do that in blue, what do we want to call it? What's the product term that corresponds to the blue loop?
A prime, C prime.
It's exactly right. And what else can we loop?
15, 17, 14, and 10. I mean, 15,
Yep.
11, 14, and 10.
Yep. And what shall we call the yellow loop?
AC.
That's exactly right. That's exactly right. So that's the don't cares, such as it is. Question number 15. What do you think? Is it who got confused by that? So you kind of saw the procedure, right? You're given essentially the truth table by virtue of the canonical sum of products form in shorthand notation, including the don't cares. And if you didn't have the don't cares, you would not get a minimal form. You get a completely, well, you would get, if the don't cares weren't there, you get a completely different answer. You remove those and your answer changes materially, right? Because now you got to loop this, and then you got to loop that, and then you got to loop this, and then you got to loop that. And by the time you're done, you got 4 loops, and each one of those is 3 variables, and it becomes a much more complicated circuit than the one that we have represented here and here. So having those don't cares really helped us out. Maybe I should leave some of these for you guys. Is there anything in particular that's difficult about question 16? I think you guys can do that, right? Do one of these on your own, I think. Let's see what else. I'm going to skip around a little bit. Well, I'll take requests. Anything else you want me to cover? Because it's looking like more don't cares. Here's one that's complicated looking. I guess we did question. You want to try question 19? That looks good. I like question 19. We can do that. So we'll do question 19. I'm skipping that because there's a lot of questions here, and it's good for you guys to do a few of these on your own, I think. And it says, given the following KMAPs. So now we're given a KMAP, which is a little bit different. I guess I'll use blue for the corners. I've already used red on everything else. So that's the KMAP we're given. Find the minimum sum of products form. All right, you tell me, what do I loop here?
Just the 4 outer corners.
Yeah, just loop the corners, that's it. Just loop the corners. Did we do this already? This looks very familiar. And if you do the outer corners, what would the product term be here?
Is it B prime, D prime?
Yep. That is exactly right. That's exactly right. Let me see if there's any other difficult ones here that we need to do. I'm just searching for tricky ones. Tricky ones. Huh. Yeah. This is looking pretty tricky. I like this one. Let's do a tricky one. No sense doing the easy ones when you can do the tricky ones. So what we'll do, let's do a
Professor?
Yeah.
It's 147.
Oh, thank you. Thank you. I'm sorry I went over a little bit. All right. So you guys have a homework to do. It's got a bunch of examples, which is really good, actually. And I think you guys ought to try them. And this is like don't cares and KMAPs, and it's gonna keep you busy because there's a lot of examples here. So give it a go, and you've got your reading. That's chapter 4, and it's snowing out, so drive safe if you're driving. Otherwise, stay home and stay warm. Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Thank you, Professor.
Thank you.
Professor, I had 2 quick questions.
Sure.
So the first one, for number 19, the one we just did, you could also loop the don't cares, right?
No,
Like in the-
No, you
Oh, no,
don't
you
loop
can't.
those. You'll get a non-minimal form. They're
Okay,
not.
even though they're all, you can't count them as ones there. Okay.
Nope. You only count them when they help you. They don't help
Okay.
you don't loop them. Okay.
Okay. And then the other question I had, and I know it's like a long ways away, but like, do you have an idea of when the final exam would be? I know it's kind of like a long ways away.
Yeah, I think they give us a finals week. Let me just check. I think finals week is right after the reading days, which would be May 6th. So sometime after May 6th and before the last day, I think, is the 14th. I would guess it's between the 7th and the 14th of May is
Okay. Yeah, no, I just wasn't sure because the reason why I'm asking is because my brother was supposed to get married this past year and they had to postpone the wedding, and it's
Aw.
May 7th. So I'm in the wedding party as well. So I just wanted to make sure, like, if it would be that day, if there would be any way that I could possibly take it before or after.
Yes. What we'll do is we'll give you 2 weeks to do it. It'll be
Oh, okay.
open book, open notes, and you could submit it anytime during the 2 weeks prior to the final date. And that'll give you enough time to actually work on it. You could print it out, start it offline, and then key in the answer key when you're ready.
Okay, that's great. No, thank you so much. I really appreciate that.
Sure thing. Thank you.
All right. Thank you, Professor. See you on Thursday.
Sounds good. Bye-bye.
Bye-bye.